Hey class, this is Mrs. Norris. This is Chapter 7, Section 4 for Geometry. So we just finished talking about similar triangles and how to prove them using AASAS or SSS similarity. This time we're going to practice applying some of the rules. Okay, so let's start by recognizing I printed this one out for you. Theorem 741 is called the triangle proportionality theorem, and it says given these two lines parallel, EF and BC, then your conclusion is that this little part here, AE over EB, is proportional to this little part, AF over FC. So remember the problems we've been doing so far, we had to add these two sides up and split them into two triangles, but now we don't have to anymore. As long as these lines are parallel, we can take this little part over this part. Now, also printed on your handout is the box for the converse of the triangle proportionality theorem. And it simply says that if a line divides two sides of a triangle proportionally, in other words, if the proportion is true, then the lines have to be parallel. So the given and conclusion from the original triangle proportionality theorem just switch places. Remember, the definition of the converse is just for the hypothesis and the conclusion to switch places. Okay, take a minute and answer question 1 about the definition of converse and why you didn't need the video to fill in the boxes. Also, make sure you do have your boxes filled in, as the directions stay on your handout. So let's fill in example 1 kind of quickly. Example 1, let's see what we're given. We're given this picture, we're given some arrows. It means the lines are parallel. We can use these parallel lines in the fact that this little angle here and this little angle here are congruent from CA's. Angle R is congruent to itself reflexive to prove that the triangles are in fact similar. Since these lines are parallel, we can use our triangle proportionality theorem. We can write a relationship that says US, the value US, this little part here, over 14 is equal to the 4, which corresponds up here to this US, over 10. Writing that out looks like this. We're going to cross multiply, and we're going to get US times 10 is equal to 14 times 4, or 56. US is equal to 56 divided by 10, or 5 3/5, or 5.6, however you want to write it. Okay, example 2 is asking us to verify that these two lines are parallel. And if we look at the converse of the triangle proportionality theorem, it says these two lines are parallel if these two little parts are proportional to each other. So we can write out a relationship comparing 10 over 15 to 8 over 12, or 10 over 8 to 15 over 12. This time we're going to take 10 over 15, which gives us 2/3, and 8 over 12, which also gives us 2/3, showing that these two ratios are equal. It means that the sides are in fact proportional to each other, and we can say because of the converse of the triangle proportionality theorem, DE is parallel to BC. Alright, example 3 is on the back of your handout, already printed for you. This is a really good real-world application. You know, artists need to use this triangle proportionality theorem all the time because in order to make the trees look like they're all parallel to each other, we need to make sure that the 4.5 inches up here and the 2.6 inches and the 4.1 inches are proportional to their counterparts down below. So if you notice in the picture, they've already labeled all these givens for us. 4.5 is from A to B, 2.6 is from B to C, and 4.1 is from C to D. In the bottom, we're only given KL. So you can realize we can figure out a whole bunch of pieces. We could figure out LM by comparing it to the 2.6. We could figure out KM by comparing it to whatever 4.5 plus 2.6 is, etc. And this problem is asking us to find LM. Since LM is right here with this 2.6, we're going to write out a ratio. And the ratio is going to be 4.9 over the unknown LM is equal to 4.5 over 2.6. You could write this out many different ways. This is how we're going to find LM. Okay, when we cross multiply, we get 4.9 times 2.6 is equal to LM times 4.5. We get LM is equal to approximately 2.8 inches. So we could fill that in as 2.8. Now, if you were to find MN, you would just say X, our unknown, or MN, over 4.1 is equal to 4.9 over 4.5. Lots of different ways to set these up. Okay, for Chapter 7, Section 4, that's all I have. You do have 2 practice problems I want you to try. I want you to try, check it out, example 1. That's printed for you on the handout. It's asking you to find PN. It should look like this. And then example 2, you have to be careful with this one. You're given BC, which is the full length, okay, and also AC. So make sure when you fill in this little BE here, you don't put 27. You put what it should be. If the full thing's 27 right here, and this one's 15, what's BE going to be? Same goes with AC. They're given AC is 36. There's a reason why they're not labeling the picture. Alright, try these 2 problems. Make sure you have your notes filled out, and I will see you tomorrow. Have a great night.